The incorrect statements regarding the geometrical isomerism. So the first option is given as propene shows the geometrical isomerism. If I am taking the propene structure CH3CH double bond CH2, this carbon is having two identical groups which cannot exhibit the geometrical isomerism. So the option A given is wrong. The trans isomer has the identical atoms of the groups on the opposite sides of the double bond. If I am going to take C double bond C, and here it will be CH3, and here it will be CH3, and here it is hydrogen, here it is the hydrogen. This is the 2-butene structure, and which can exhibit the geometrical isomerism. And hydrogen is there, and the opposite side hydrogen is also there. Here methyl is there, here also methyl is there. So which is a trans 2-butene. Trans 2-butene. So the two similar groups are present on the opposite side of the double bond, which is the correct statement for the given question. And cis 2-butene has a higher dipole moment than the trans 2-butene. If I am going to take the cis, C double bond C, single bond CH3, single bond CH3, and here it is the hydrogen, and here it is the hydrogen. Methyl is an electron donating group. This methyl is an also electron donating group. Two are donating in the same direction, that's why it is having a higher dipole moment. But if I am going to take trans, the direction for this methyl group is like this, and the direction for the methyl group is like this, and both are in the opposite direction. So the resultant dipole moment will be cancelled. So trans 2-butene is having the dipole moment is equal to 0. So C is also correct. 2-methyl 2-butene shows the geometrical isomers, two geometrical isomers. So here it is C, single bond C, single bond C, single bond C, and here it will be double bond, and the second carbon is having CH3, and here also CH3. This particular carbon is having the same methyl groups which will not exhibit the geometrical isomerism. So which is the wrong answer. Trans isomer having high melting point when compared to, lower melting point when compared to cis. So in general, trans is having symmetrical structure when compared to cis. That's why the melting point is more for trans when compared to cis. So it is lower melting point it is given. So E is also wrong. So the correct statements for this question is, incorrect statements for this question is A, D, E. A, D, E is there an option 1 which is the correct answer for the given question. So the number of molecular ions which will show the linear geometry. So SO2 is given S double bond O double bond O. Here the sulfur is having 2 bond pairs and the 2 lone pairs. sp3 hybridization. The shape of the molecule is angular or the bend shape, which is not having that particular linear. If I am going to take BeCl2, the central atom beryllium, having 2 bond pairs and the 0 lone pairs, sp hybridization, and the geometry is linear, which is the correct answer for the given question. And the next one, CO2. CO2 structure can be written as C double bond O double bond O. The central atom C is having 2 bond pairs and 0 lone pairs. sp hybridization 2 plus 0 2 sp hybridization, and here it will be linear, which is also a correct answer for this question. N3 minus, which is called as azide ion, N double bond, and here it is the positive charge and the negative charge. The central atom nitrogen is having 2 bond pairs and 0 lone pairs. So sp hybridization, and here it will be linear, which is the correct answer. NO2, N double bond O, and the 2 bond towards the nitrogen, and this one is in angular shape with the sp2 hybridization. sp2. So which is also correct, wrong answer for the linear geometry. F2O, O single bond F, single bond F. So oxygen is having 2 bond pairs. Out of the 6 valence electrons, 2 are involved in bonding, 4 left. That's what is having 2 lone pairs. sp3 hybridization, angular, which is also not correct answer for the given question. XeF2, the central atom xenon, having 8 valence electrons. Out of 8, 2 are involved in bonding, 2 bond pairs. Still it is having 6 electrons which are not involved in bonding. That's with 3 lone pairs, 2 plus 3, sp3d. 2 plus 3, 5 hybrid orbitals are there in sp3d, and which is having the geometry linear. Correct answer. NO2 is angular, which is having one odd electron. If the odd electron is missed, then you can get NO2 plus. That will be sp hybridization and linear, which is the correct answer. And I3 minus, the central atom iodine is also having 2 bond pairs and 3 lone pairs. sp3d hybridization linear, which is the correct answer. Ozone, O double bond 1, D2 bond towards oxygen. The central atom oxygen is sp2 hybridized and angular geometry, so which is the wrong answer. So linear geometry is there for 1, 2, 3, 4, 5. 5 is the correct answer for this question.